Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching Astronomy Live.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop.
Hi folks, welcome to Astronomy Live. Tonight, we're tracking asteroid 2023 DZ2, a near-Earth asteroid currently approaching Earth, newly discovered, and will pass by Earth at about 0.45 times the distance to the Moon. It's a faint little dot in this image. Currently, apparent magnitude, according to JPL Horizons, is estimated to be about magnitude 13.7. So this is far below the brightness that would be required to see it by eye, or even with binoculars, really. You need a good telescope for this. So let me put a little pointer on here so you guys can see where it is. I'm currently directly tracking the asteroid using my NEOTraker software. That's available, the source code is available on GitHub, and I'll post that in the chat here in just a second. So here's the source code for the tracking software I developed and I'm using tonight to directly track the asteroid. And for the tracking data, I'm using JPL Horizons to download the orbital elements of the asteroid and load it into my software. So tonight I'm going to be imaging with an 8-inch, well, actually imaging with an Orion ST80. It's an achromatic refractor riding piggyback on an 8-inch LX200 Classic. And the camera is an SBIG ST2000 XCM. Set the outside light color to red. Goes. Okay, dimming my exterior lighting and setting it to red so that it won't impact the image, hopefully. Double checking that I am saving the images to my hard drive, and I am. Don't want to get through the night and found out I actually haven't saved these images. At the end, I'll be able to process these into a time-lapse video. So if you stay to the end of the webcast, we should have a time-lapse of the images collected here of the asteroid. So again, the telescope is directly tracking the asteroid. The stars are the streaks, and they're streaking because the telescope is directly tracking the motion of the asteroid based on its orbital elements. I'm running 1-minute long exposures here. This SBIG camera is a single-shot color camera. So the color is real, though the purple fringing around some of the brighter stars is due to the cheap achromatic refractor I'm using to actually do imaging with. The average layperson probably honestly doesn't notice or really mind, but anyone who's experienced in astrophotography is going to tell you that I need to get a better lens. I'm not shooting through the main telescope tonight because, well, for one thing, the asteroid is moving fast. It's moving fast enough that it doesn't make sense to do the adaptive optics unit with the main telescope and guide on a star, because the asteroid will be just a streak, a faint streak through the images, and I'll have to keep moving the telescope to keep up with it, which would get annoying very quickly. For me. Maybe not as much for you guys, but for me, I'd have to be constantly chasing it. And if I try to do direct tracking, with the LX200, I don't have direct control of the drive rates. And so the resolution of the speed that I can move is fairly limited, actually, because of the format. Partly because of the format accepted by the telescope for direct go-to slews. So it's actually better, this scope's actually better at doing tracking of things that are moving relatively quickly through the sky, like my Artemis 1 launch footage was actually filmed with this telescope. It can handle that tracking just fine. But when an object like an asteroid is moving relatively slowly in the right ascension axis, then it doesn't make sense to do it through the main telescope. The motion would be too jerky. It can even be seen kind of jerking from position to position in these refractor images, though it's not as distracting from the aesthetics of it, unless you really know what you're looking for. If you look at the stars, though they're streaks, they're segmented streaks. There's like little staccato dots in the streak. It's not really a smooth line, and that's because the telescope is moving in discrete steps. And those discrete steps, again, are the limitation of the way this old telescope works. It can only accept coordinates to essentially a certain number of decimal places past the degree point. Really, it's accepting it in hours, minutes, seconds in right ascension. And it can't do decimal seconds of right ascension. And that limits the resolution with which it can move to a discrete location. And so what you end up getting is, if I were imaging through the main telescope at higher magnification on the asteroid, then the asteroid would not be stationary like this. It's this nice little dot in the image where you can very clearly see the asteroid doesn't look like it's moving much during the image, but the stars move from image to image. But if I had it through the main telescope, you would definitely see the asteroid streaking along for a few seconds, and then the telescope would jump to the next position, and the asteroid would streak along, and it would jump to the next position. So you would end up with a final image, although it would be through the main telescope. You would get stars that are still these dots that are now more separated apart, discrete points where there's stars, and then you would have this muddy streak in the middle of the asteroid instead of a nice, clean dot. So to get the best image, you actually want to zoom out more to deal with the limitations of this telescope mount. So in order to do that, I'm using a refractor, hence why I'm using the Orion ST80 to image tonight. The ultimate product of that isn't too bad, really. I can zoom out here a little bit. Now I've messed up my marker, but let's see, it's down here. But I mean, you get a nice wide field image, you get some colorful stars. Yes, there's color fringing on it, and definitely that is not the preference of anyone who does real serious deep space astrophotography. That's or even planetary photography. That's less than ideal, as they say. But the average person, honestly, in my experience, doesn't really notice or care. It's the more seasoned connoisseurs of space images that would notice this limitation of the optics. But for a live stream for tonight, I think this looks good. We've got good tracking on the asteroid, direct tracking again with NEOTraker, and you can find a link to that in the video description, or I'll put it in the video description. Don't think it's there yet. Let's see. Let's put that in the video description. There we go. So yeah, I'm pretty happy with what we got here. Now, it will slowly drift. For one reason is that I'm using static fixed orbital elements for the asteroid to track it. In reality, those elements are changing now under the force of Earth's gravity. That's accounted for in NASA's calculations, in the Minor Planet Center's calculations. So they've already accounted for that in determining how close this asteroid's going to get. And it's going to get within about 0.45 times the distance to the Moon. Specifically 0.455, I think, which comes out to about 175,000 kilometers at closest approach. And closest approach will actually be tomorrow afternoon during the day here in Florida, so I won't be able to see the moment of closest approach. But right now it's approaching Earth for its closest approach. Now, this asteroid was newly discovered, and as a result, we don't have a whole lot of data on its orbit. The orbit determination is pretty uncertain at the moment for the future. And let me see, NASA Sentry website, what the current status of this one is. It must have been any. Huh. I wonder if they ruled out the impacts on it. Maybe they did. Maybe they did. I don't see any records now. Let's see the list of removed objects. Yep, they've removed it. So they must have enough data now to rule out the impacts. It did have a possibility of actually hitting Earth in 2026 when it was first found, but it looks like that's now been pretty much ruled out, which is good news. Now, in terms of the asteroid's size, we can make assumptions about the size based on assuming the reflectivity, essentially. So that's the way it's done before we get radar data. And as far as I know, we don't have radar data yet on this object. So what you do is you look at the brightness and you say, okay, assuming it was a highly reflective asteroid, it would be on the smaller end of the scale. Assuming it's a very dark asteroid and doesn't reflect much light, then that would imply it's a larger object on the high end of the scale. Now, on the high end of the scale, if we assume this asteroid is as dark as fresh asphalt, reflecting about 5%, maybe a little less, of the light that hits it, that would imply it's an asteroid roughly 88 meters in size. And for some reason, the media has somewhat recently, taken to describing the sizes of asteroids in ridiculous units. Giraffes, alligators. So, I've decided to invent my own ridiculous unit. So, if we assume that this asteroid is on the darker side of things, and maybe as reflective as fresh asphalt, maybe about 5% reflectivity, then its brightness implies a size of about 88 meters, if I did the math right. And given that size, if we take the focal length of the telescope that I'm using to image it right now as 400 millimeters, that means it's roughly the size of 220 of my telescope. So there you go. There's the new scale for measuring the asteroid size. Telescopes. It's 220 telescopes wide. Definitely big enough that you don't want it landing on your house, but small enough that it can slip by almost undetected. These things have to be very close to Earth to be bright enough to be detected, and that means that if you detect it on the orbit that it's going to hit you, you're not going to get much warning. You're not going to get enough warning to really do anything about it, except maybe try to get out of the way. Fortunately, if this one had been set for an impact in, say, 2026, we've discovered it in 2023, maybe we can mount some sort of DART-like mission to try to redirect it. But the other issue is, not only do you have to get your rocket ready and your payload ready to divert the asteroid, But the sooner that you start that process of trying to divert it, the less force, the less energy you have to impart to the asteroid to successfully avert a collision. The closer you get to impact, the more delta V, or change in velocity, that you have to impart to the asteroid to prevent a collision from happening. So that's why it's important to survey the sky and try to find these things. And because you can only detect them when they're close to Earth, you have to do this process constantly. You can't just survey the sky once and say, okay, I found everything. No, you really haven't. You've only found, at best, what was available and close by at that time. Magnitude 12.9, according to JPL. I'm just going off of JPL's estimate of the apparent magnitude. That sounds like maybe, I thought it'd even get brighter than that. Yeah, by tomorrow morning at close approach it should be magnitude 10 if you could see it from Florida, but you can't. Right now, according to JPL Horizons, what are we at? 9:15 Eastern here. The estimated apparent magnitude is 13.743. So, give or take, it's going to be dimmer than magnitude 13 right now, according to JPL Horizons. Now, I also looked at the data for Sky Safari Pro, which also has it listed, but I would say Sky Safari's trajectory data on it is not the most accurate. They're also going to be using static orbital elements that are at an epoch of February 25th. So think of it like this. It's like the orbit elements haven't been updated. They've been updated, but not necessarily in Sky Safari's database since February 25th. And the gravity of the planets has affected the asteroid since then. Certainly now it's approaching Earth closely. So it's going to be a little bit differently positioned than what Sky Safari says. So that can also impact the apparent magnitude, the distance it shows, all of that is not necessarily going to be the most accurate. Though right now, it does say 13.7 on Sky Safari, so it's not too far off. Furlongs per fortnight. I've not seen that units for velocity before. I like it, though. So I'm just going to share the stream out here to my Twitter again. I tried to advertise it on Twitter before, but I don't know how much traction it really got. Just want to update people that we can see it right now. Alright, how are we doing on tracking the asteroid? Looks good. Just as a side note, I tried to put fresh desiccant in the camera this morning before I left for work and hoped that it would pull the humidity out by tonight. Turns out the answer is no, it did not. Which it had well over 12 hours to drop the humidity in the CCD chamber. Which tells me two things. One, I need to buy more desiccant, because the desiccant I have is no good. I even microwaved it to try to push the humidity out of it and make it function better. Didn't work. And number two, I need to change the desiccant in this camera more often, because it's full of humidity. So this camera is thermoelectrically cooled. That's why it shows a temperature down there in the bottom right of 2 degrees Celsius, and it's trying to hold that set point. It can drop sub-zero, but the moment I do that, because there's humidity in the CCD chamber, it will form ice crystals on the CCD, and it will obscure the view. So we don't want that. So I got to keep it at positive Celsius, above zero. But the cooler you can run the camera, the less noise you get in the image. So just have to live with a slightly warmer than usual CCD tonight, unfortunately. But for this target, I don't think it really matters. We're not trying to image a very dim nebula or galaxy or anything like that tonight. We're going after what is, to this telescoping camera, a relatively bright object. But again, it is many times too dim to see by eye. The trained observer with averted vision under perfectly dark skies can only see down to about magnitude 7 at best. And the magnitude scale is logarithmic, it's not linear. It must be Friday night. Springtime, but somebody's playing a game of some sort. You can hear the, I don't know if it's coming through on the microphone, probably not, but I can hear the announcements over the loudspeakers at some high school game in the distance, I suspect. So if we assume this asteroid is magnitude 13, and we assume that under perfect conditions with averted vision, where you're not looking directly at the object, because actually the sensitive rods in your eye are more concentrated at the peripheral of your vision than in the fovea in the center of your vision. And you can see down to magnitude 7. This object, even at magnitude 13, is 250 times too dim to see. So unfortunately no one will be seeing it by eye tonight, but you know, maybe that's a good thing, because if they could, that means it's a lot closer. The other good thing is that because it was discovered early enough in this particular pass, they've already been able to rule out future impacts from just the data collected so far, at least for the foreseeable future. And that means the orbit is being refined over time by collecting more observations. It's not just about how big your, to some extent it's about how big and accurate your telescope is, but to a larger extent, it's about how long you can observe it. If you only observe it over a single night, you don't have enough data to know for sure exactly where it's going to be years into the future. Let's see, what's the condition code right now on the JPL? So right now they list it as condition code 5, so it's moderate uncertainty. 0 is the best. 0 is where they know the orbit with high precision far into the future. 9 is where it's completely uncertain, and unless you just saw it in the last couple nights, you have no idea where it's going to be in the future. So 5 is moderately good. Apparently good enough at least to rule out impacts in the immediate future. They actually have a 68 arc of observations now. First observation January. Probably a pre-discovery image. Let's see. Let's go to Minor Planet Center. So sometimes when an object is found, they'll actually find observations that predate its discovery. Maybe it was seen for a single night, but the observations weren't good enough to detect it, or not good enough to identify an orbit for it, even a rough orbit. And so once you have a better determination of it when it's actually discovered, and you've got a nice set of images that at least give you an approximate initial orbit, you can trace that backwards in time to see if it matches where any major observatories were observing at previous dates, and they might have seen it and not realized that they caught it. So yeah, it looks like Mount Lemmon picked it up on February 11th. La Palma picked it up on February 27th. Those are single night sort of observations. You have Pan-STARRS 2 on January 14th. Kit Peak on January 28th. A bunch of individual dates that it happened to be in a telescope, but most of the observations start around March. First discovered February 27th at La Palma. There you go. So yeah, it has some pre-discovery images that were found in the weeks and even over a month before it was actually discovered. Where for single nights, it happened to pass through the field of view of a major observatory, and by identifying it and getting an approximate orbit on it, they were able to trace that back and actually find images that contained the asteroid before it was formally discovered. That helps refine the orbit quite a bit, because again, time is a critical factor in determining the orbit. And so because we have observations that span multiple months now, we're able to rule out the impact in 2026. That was an initial possibility. Yep, Tony Dunn's on. Thanks, Tony. Yeah, I'm just catching up. I was just browsing Minor Planet Center trying to find the discovery date there. Yeah, baking in a conventional oven for desiccant does work quite well. These cameras, I've got two of these S-Big ST2000 cameras. They actually come with a rechargeable desiccant that's designed to be baked. It's in a nice metal canister. So you're supposed to bake it in the oven for a couple hours at, like, I forget exactly what temperature, but you got to keep it a little low so you don't melt the solder or whatever in the metal canister. But that's a time-consuming thing. I guess I'm just lazy these days, so I just want to pop in some fresh desiccant. So I just order some off Amazon in those little paper packs, and there's an optional accessory that I have for both these cameras that lets you use just standard paper packs of desiccant that you might buy off Amazon. Same kind of stuff you'd find in your pill bottles, basically. And you can just cram a fresh one of those down that canister and seal it shut, and then use that. Here in Florida, of course, we have a lot of humidity, and the desiccant only lasts for about 6 months at best, in my experience. And yeah, I can nuke it in the microwave for a little bit to try to heat it up and get it to go again. I tried that this morning, and apparently it wasn't good enough, so have to hit it again with some more fresh desiccant. But anyway, on a personal note, I've made getting this live stream up and running my first priority for tonight, so I actually haven't eaten anything. I'm going to fire up my oven real quick, not to heat up some desiccant, but to heat up some food, and I'll be right back. But I'll leave you guys with a little bit of music here, courtesy of Stellar Drone, so I'll be back in just a few minutes. Alright, my oven is preheating, and looks like we've still got Asteroid 2023 DZ2 right where we left it. Will this destroy us? No, it won't. Thankfully, it'll pass by quite safely. Let's see, let's grab some statistics on its current distance. So we're at 9:39 Eastern right now. Okay, current distance from the telescope. Is that right? Yeah, that's delta. Current distance 520,000 kilometers. 520,511 to be exact. So it's still further from the Earth than the Moon at the moment, though that will change. In terms of lunar distances, that is equivalent to 1.35 times the distance to the Moon. Closest approach will occur tomorrow at about 3:51 p.m. Eastern Time. Thank you. I'm glad I could bring it to you guys here live. It's a great question. What does DZ2 stand for? So, it's a systematic designation in reality. It tells you when it was discovered and the order in which it was discovered. It doesn't really stand for anything. So, it's the half month and the order in which that asteroid was discovered. So, let's see. So here's a good website that covers, I'll put it in the chat here. This covers how asteroid designations are made. So you can see on that page how the half month designates the letter. So because this was discovered in late February, it gets the letter D for the back half of February. So then you go into the second letter, and that tells you, that has to do with the order of discovery. So the first one would be A, and it goes up through Z, of course, and then you have numbers after that for cycling through the alphabet. Yep, exactly right, Tony Dunn. So that D is second half of February. That's how you know January observations were pre-coveries. That's right. I think there was some disreputable news site that was trying to say that the pre-discovery images were evidence they were hiding it from us. They were sitting on the discovery. No, that's not really how that works. As discussed, generally what happens is you have an asteroid discovery like this, especially if it's a near-Earth asteroid, a potentially hazardous asteroid. They'll do a search for images that predate the discovery to see if it happened to be in any of those images from major observatories, and that helps nail down the orbit because time is an important factor. Doesn't mean someone was sitting on the discovery, believe me, we all want credit for our discoveries. Just means that they found an image containing the asteroid that was taken before it was actually discovered. Follow-up question. What part of the sky or constellation is the asteroid currently in? I believe it's in the constellation Cancer, though I left my phone inside. Oh, no, I didn't. I forgot I had the phone running, taking a photo of the telescope. Got a lot of wires in the foreground, but it's not so shabby of a picture anyway, of the lighting. But I believe it's in Cancer right now. Let me just verify that with Sky Safari here. Yep. It's currently in the constellation Cancer. Do I think there's a probability of it hitting Earth in 2046? Apparently not. So I checked the Sentry site, which lists all possible impacts, and they've actually removed this asteroid from the list because they've apparently ruled out those impacts, those impact possibilities, now with the amount of data that they have on this asteroid. So that's the good news. We can sleep soundly from this asteroid. It's really the ones you don't know about that are generally the biggest risk. In fact, some of the risk scales compare the risk of any particular asteroid hitting us compared to the background risk that one just hits us. Like Chelyabinsk, where you have an asteroid coming from the daylit side of Earth, coming from the direction of the sun roughly in the sky, where it's not really observable on that orbit before impact, and it just hits. And there's no warning, and there's no way to see it coming, at least on that particular orbit. But there have been asteroids discovered shortly before impact, but they've all been small, making fireballs in the sky and this kind of thing. 2046 was the year 2023 DW might have hit. This one might have hit in 2026, but has been ruled out. Okay, yeah. DW. Oh, that's right. That was that other one. Yeah. Thank you, Tony. Appreciate it. Tony Dunn, by the way, go follow him on Twitter if you don't already. He keeps me up to date on this stuff. He's always watching out for the latest asteroid discoveries and making excellent graphics, plots, and animations of their passes with his software. So go check him out on Twitter. Oh, my pleasure, Tony. Yeah, definitely follow Tony. He's worth a follow. Well, it looks like my oven's finished preheating, so I'm gonna go pop my food in the oven and I'll be right back. Alright, I've got another 18 minutes on my fish cooking in the oven. Some media say you will be able to see it with binoculars when it's closest in 18 hours from now. Is that likely? How are we able to see it? Is a dot moving across the sky? Great question. According to JPL, at least if I could see it from Florida, it'd be about magnitude 10 at closest approach. Yeah, I think that might be doable with binoculars, but you'd have to know right where to look. And the other problem is, unfortunately, here in Florida, that's going to be during the day. So if you're in the United States, then we're pretty much out of luck on that one. It's not going to get bright enough for binoculars tonight. It would have to be later into tomorrow, closer to the time of closest approach. If you're on the other side of the world, then yes, theoretically, it should be possible to see it, with binoculars. But even tonight, before it reaches closest approach, even though it's still further than the moon, it's large enough that an amateur telescope like the 80mm refractor I'm using is able to see it with a deep space camera. And actually, occurs to me that I do have an eyepiece on the main telescope right now. Let me take a peek. I'm curious if I can see it through the main telescope. It should be co-aligned relatively well with the refractor, relatively speaking. Let's see, how close are we to the center of the image? Not super close. I don't know. It might not be in the field of view of the eyepiece that I've got in there. We'll see. I want to see if I can see anything. Okay, gotta move my marker now. It's here. Here it is. Okay. Let me see what I can see through the main telescope. I'm curious if I can see it. Okay, I can see a couple of stars through the main telescope, including one that I think is probably the asteroid, but it's hard to say. It's pretty sparse. It's really quite hard to say. I'm going to take one more look and see if I can tell if it's moving. It's real hard to tell if it's moving against the other stars. Yeah, it's difficult to say. I can't say with any certainty whether I'm seeing it in the main telescope or not. Maybe if I come back in another 10-20 minutes and I still see the same star-like object in the same spot in the eyepiece, that would tell me that, yeah, I'm probably seeing it. But hard to say. Yeah, it's best I can tell. 40 to 90 meters sounds reasonable. I calculated it at about 88 meters, assuming it was pretty dark as an asteroid, about as dark as asphalt, kind of on the high end of the size spectrum. because it's all dependent on how reflective the asteroid is. We're just measuring the size based on its brightness and assuming a reflectivity. You can assume it's dark, in which case your calculation will suggest it's on the large size. If you assume it's highly reflective, then the calculation comes out on the smaller end of the scale of possible sizes. And as Tony Dunn says, if it were 20 miles across, it would be naked eye, for sure. In terms of larger asteroids, though, there's also some other interesting goings-ons with much larger asteroids, or the largest asteroid, Ceres. So Ceres is going to be passing in front of the spiral galaxy M100 this weekend. So if it's clear Sunday night and I shoot M100, you would actually see the asteroid Ceres moving slowly across the galaxy. I might fire up some time on some eye telescopes. Probably not going to set up my own equipment that night, but might try to fire up some time on some eye telescopes to shoot that conjunction of the asteroid Ceres and Messier 100. Oh, we just had a satellite. I must have missed it. I was taking another peek through the telescope. Let's see if I can happen to identify it. Oh. Yeah. So the satellite, ooh. USA 99 Milstar 1. 1-1 or 1? I'm not sure. 1994-009A. So this would have been a military satellite, probably a classified satellite launched in 1994. That's what passed through the field of view. Well, I sure hope the military doesn't get mad at me for accidentally catching one of their birds. So we've collected just over an hour of images of the asteroid so far. I'm going to try to process the images into a interim time lapse of the first hour of light, and I'll be right back. I'm going to do that on my desktop real quick and export a video. So give me just a minute. Alright, so here is the time lapse of the first 65 minutes of light of images. You can see hot pixels. Those are the perfectly stationary pixels in the frame. But that little dot that is wiggling slowly to the left, that is the asteroid. The telescope's tracking it as best it can, but there's a little bit of periodic error there causing the wiggle, and then overall motion probably mostly coming from the fact that the orbital elements it's using are static orbital elements, fixed orbital elements. You can see quite a few satellites streaking through the view there, like laser beams shooting in the time-lapse there. That's pretty cool. I wonder if I can... Yeah, let's shrink this up a little bit so it doesn't occupy the whole frame. Just crop that in a little bit. So we'll have the live view here. Cursor over to the opposite side here. There we go. That's not too bad, is it? Thanks, Tony. Alright, well, my fish is now ready, so I'm gonna go eat a bite of fish and let this continue to run, continue to collect more images, and at the end of it, we'll have an even better time-lapse. So, I'll be back... Oops, didn't mean to turn that off. I'll be back in just a few. Till then, enjoy the asteroid and some sounds from Stellar Drone. Sorry I had some network troubles there. I noticed the stream wasn't doing so healthy good, and for some reason my desktop was sucking up all the upstream bandwidth. I think it was syncing all the files that it processed when it made this time lapse, and that threw off the network. So I have shut down the internet for the desktop for the time being, which will hopefully improve the upstream bandwidth for the laptop running the actual stream with the telescope. So apologies for that interruption. Hopefully things are more stable now. Alright, enjoy. And I'm back. Ate some fish. Have myself a nice little beer here from Playland Brewery. Luna Lemonade. Luna Lemonade. If you ever happen to take a trip over to the Cape to see a launch, you're looking for a place to have a drink, highly recommend either of Playland or Brewery's locations. They got some excellent brews. Looks like we're not too far past the meridian at this point. So the asteroid has passed the highest point in the sky, roughly. So yeah, the time lapse on the right, that's from about the first hour of data, about 65 minutes of light. Not accounting for overhead between downloading each image, but 65 1-minute exposures. You can obviously see a bit of motion of the asteroid from the tracking. But I want to say you can also see some oscillation in the brightness of the asteroid on top of that. And I don't think that's from the tracking, the periodic error of the tracking. I suspect that is real from the rotation of the asteroid. Asteroids this size aren't necessarily nice round balls. They can be quite lumpy, quite oblong in shape. And so even if they're roughly the same brightness or reflectivity all the way around the rock, depending on how that shape is oriented to you, there's going to be a different amount of surface area reflecting sunlight back to you. So the rotation of the asteroid will naturally impart a variation in the light curve, a variation in the brightness over time. And with asteroids this size, they can frequently be quite fast at rotating, completing a rotation in minutes in some cases. So we might well be seeing the rotation of the asteroid and how the brightness of it varies and appears to strobe in brightness across a few frames. Again, each frame is 1 minute long for the exposure. So some of these asteroids can actually spin themselves apart. The rotational speed can increase over time due to variations in the reflectivity across the surface and how solar radiation pressure can exert a torque on the asteroid. It's called the Yorp effect. Yarkovsky, O'Keefe, and I'm not going to even try to pronounce what looks like a Russian name there, Empatic effect or Yorp effect. is caused by solar radiation pressure essentially altering the spin of the asteroid over time. And if it causes it to spin up enough, it can actually cause the asteroid to start to lose mass. It can actually rip it apart over time, because the gravity of these things holding themselves together is quite low. I mean, these are little asteroids, you know, only some number of dozens of meters in size. And so there's not a whole lot of gravity there to have to overcome. And when you get up enough of a spin, it will overcome the internal gravity of the asteroid and actually cause it to start to fall apart. And there have been, I believe, examples of that have been observed. Something is moving over here in my yard. Oh, what is it? It's probably a bunny. Hopefully I'm not messing with my image quality too much with the flashlight, but hang on a second, I need to investigate. Oh yeah. 2 bunnies, and they're right next to me. That's what I thought. I heard him in the dark. Yeah, hi there. I don't think they appreciated me noticing their presence. Oh, sure. Sure, Alpha. So this is an 8-inch LX200, which is just serving as the mount. It's polar aligned on a wedge, and the imaging is through an Orion ST80 refractor, just a simple achromat, with an SBIG ST2000 XCM single-shot color camera, doing the imaging. Tracking the asteroid with my NEOTraker software. It's open source, it's very much a work in progress. It's kind of messy right now, to be honest. I haven't done any cleanup on the code lately, and I only recently implemented, embarrassed to say, I only recently implemented equatorial options for tracking with the LX200. First few times I've used NEOTraker, I just ran it in altitude azimuth mode. But selfishly, necessity is the mother of invention, and so when I realized I wanted to do some equatorial tracking of asteroids, I implemented an option to switch mount type, but it's not very obvious how to operate it right now. It's a little bit goofy. But there's a drop-down tab for mount type, equatorial or altaz. And even though the telescope type says only LX200 altaz, the mount type will actually override that and go to equatorial, for equatorial-based tracking like this. Like I say, it's a bit untidy at the moment. I need to tidy up that code, but I've been putting more work into coding Rocket Tracker right now, and implementing an options menu for joysticks and this kind of thing. Trying to work on the remote tracking options for UFO Tracker / Rocket Tracker now, which is another program I've written specifically, obviously, as the name implies, for tracking rocket launches. But there's my GitHub with NEOTraker. Thank you, Alpha. I hope it works for you. NEOTraker ostensibly supports ASCOM-based tracking, though I've never once actually tested it on a real asteroid with ASCOM-based tracking, so your mileage may vary, but it is open source if you want to test it and make corrections to it. I keep telling myself one day I'll drag out the 11-inch to actually test the ASCOM method of asteroid tracking with it, but I have not yet done that. I've got an 11-inch next star, which will be compatible with the ASCOM method, but as I mentioned, currently untested. Since I've still got something of a crowd here, probably my more dedicated viewers at 11 o'clock at night Eastern Time, wanted to discuss with you guys, if you're still hanging around here in chat, what you want to see on the channel going forward. So I recently did a review video for a Chinese-made telescope. That was this video I just published last night on the channel, and I didn't honestly expect it to go gangbusters or anything. I mean, it's a very low-end, entry-level at best telescope, and it's got a number of drawbacks that I covered in my review. And yeah, I mean, I didn't expect the reception to be great, but I also didn't expect to lose, you know, net 3 subscribers over it. You know, I thought it'd be interesting to accept their request for me to do this review. I certainly wasn't going to do a paid product promotion for them. I just wasn't going to do that. But I offered to review their scope. They wanted me to promote their scope. I said, well, I'll tell you what, you guys don't pay me anything. Just send me the scope and I'll review it. How about that? And they accepted. To their credit, they accepted. And to their credit, they let me publish the video after I, you know, pointed out some of its drawbacks. And even said, as I said in the video, honestly, if you're in the market for something at that price level, my first recommendation is get a pair of binoculars and learn how to navigate the sky. So I think my review was fair, but, you know, it was paid product, I guess, paid product appearance in a way, because they paid for the scope. They sent it to me free of charge. And maybe that didn't resonate well with people. You know, maybe that felt a little icky to some people, and I get it if so. I get it. My hope was that it could be the first in a direction of moving in the direction of, you know, reviewing astronomical equipment if companies want to send me, you know, a review unit to test something, whether it's a camera or a telescope or what have you, and just, you know, show the pros and cons of it, whether it's good, bad, or otherwise. But I definitely get the feeling that's not necessarily what people want. Maybe that space has enough content creators in it already, you know, kind of a saturated market probably. There's a lot of great content creators out there, even specifically with regards to telescopes, that cover that kind of thing probably better than I can. Hey, Renee. They'll get over it. I mean, yeah, but I different strokes for different folks, you know, whatever floats your boat. Honestly, I had advice from people I trust that told me, don't even do it. Don't even, you know, accept their offer. Just don't bother. Maybe they were right. I'm just wondering, in hindsight, were they right? Ooh, satellite. I see a satellite. Alright, what are you? It's relatively slow moving, and at this time of night it's got to be high altitude, probably geostationary or geosynchronous distance. Oh my goodness, Wait, what? No, it's back. It's back. USA 99. Milstar 1. 1994 009A. Yeah. That's the same bloody satellite I saw earlier. How does that happen? Oh. That's the same military satellite we saw earlier. That's the first time I've seen that happen. I mean, I'll explain in a minute, but that's the first time I've seen that happen. Where the same satellite has appeared in my field of view twice in one night. Inclination, yeah. It's geosynchronous, but not geostationary. Inclination 15.797 degrees. I think that has to do with why it's able to appear twice. But I'm just going to confirm that really is the same object that we saw earlier. Milstar, yeah, USA 99, Milstar 1. Great, okay, wait. Oh. Okay, that's not what I'm seeing right now. Okay, it can't be. Wait. Okay. Yes and no. Okay, so I have a new kind of theory about what's going on here. So that was USA 99 Milstar 1 just now, but I'm seriously questioning whether I saw it earlier or not. I think maybe earlier I thought I was identifying the right satellite, but I had the hour set wrong, and I was actually predicting instead of identifying. I thought I was identifying what had gone through before, but now I'm thinking maybe I just accidentally predicted a satellite that would pass through instead of something that was passing through. It must be, because I don't think it would have appeared this soon. Yeah, there's no way. I thought for a moment maybe this was like geosynchronous satellites, not geostationary satellites. Geosynchronous satellites have some inclination to them. And so they, instead of remaining in one spot above the Earth over the course of the day and through the night, they'll appear to form a racetrack pattern, a figure 8 pattern over the Earth. And so I thought maybe we were like looking at the, you know, kind of near the loopy part at the end of at one end of the figure 8 pattern, where it went through one direction and came back through the other, maybe. But I don't think that's what it was. I think it was just an accident that I thought I had identified this earlier. I know I called it, I'm pretty sure I called it out on stream as USA 99, and I think I just had the time set wrong. And so, instead of identifying a satellite, I think I was accidentally I think I was accidentally predicting a satellite that would pass through. But I'm just gonna double check, because that would be wild if it showed up twice. And I think maybe not impossible at this field of view, but yeah, that's all it was. I just called it out early. That's all it was. I thought I was identifying what we had been seeing, and instead I had the time set wrong on the app, and so it was showing me what was about to happen later that evening, later tonight, which was now USA 99, Milstar 1. Oh well, that's funny. That's still funny to me, but yes, a plane just flew over. If they both orbit in the ecliptic, that's an explanation. Yeah, in the case of Earth orbiting satellite, that's not necessarily. It's a little bit tricky. But it is theoretically possible if you, depending on the eccentricity and the inclination of a geosynchronous satellite, you could maybe at a wide field of view catch it kind of looping around at the top or bottom of its ground track for the day. Somebody has to review equipment. If you do it honestly, and it seems you did, you've done the best you can do. I mean, yeah, that's how I felt going into it. In hindsight, I don't... In that particular situation, I wasn't so happy about having to hand over my video to them for their approval. Now, to their credit, they gave approval without asking for me to change anything. But that felt icky, just the setup for it, where they had veto authority over my review. I didn't like that. Now, maybe that was just the nature of the company I was working with there, you know, maybe another company wouldn't have those kinds of terms on me. But it definitely, like, whether I like it or not, there's going to be inherent influence in how that affects me and how I review it. I can try to be as impartial as I want to be, and believe me, I try, but there's that thing in the back of my mind where I know, you know, if I just trash these guys, they're going to say, no, you can't post that. Now, you know my channel, if you've seen my other videos. I don't exactly go around bad-mouthing, you know, people like that. I will debunk nonsense, but I don't go around bad-mouthing people. So it's not like that would be my style anyway. However, I can't help but think that there is a chilling effect on speech with how that whole process is set up and structured, at least in that particular case. And so, yeah, to Omter's comment, the video did seem more like it was promoting than a review. I can see how it came across that way, certainly, and I think that's valid criticism. Certainly, the whole front end of the review is just trying to show how to use it, right? How to use the product. Because the product, by its very nature, is intended for very beginner people. Like, I didn't even go into it, but it came with a, you know, planisphere type thing and some very basic instructions. It's obviously intended for kids or people who are very new to the hobby. That's the target audience there. And so I thought it only fair to, you know, demonstrate the product first. That said, I also had, you know, they had a certain deadline for when they wanted this published by, and they wanted the ability to review it, right? So I couldn't exactly say at the end of the video, whatever you do, don't buy this product. But what I could say is, you know, I strongly recommend you get binoculars first. I think that's, you know, the best use of your money and your time. And so it's all about how you say it, right? And so I tried to be as diplomatic as possible, because at the end of the day, I still have to be able to publish the video. If I just make fun of the thing, they're never going to let me publish it, right? So that's a problem. That's an inherent problem with how to do that, right? On the other hand, if I didn't get it for free, there was no way I was going to spend $350 just to review it. So that doesn't make any sense either. So it's a conundrum, I think. Yes, Leaf, this is real. And it's live. Anyway, I guess at the end of the day, what I'm trying to say is I probably won't do that again unless the company offers it with the understanding that I get to publish no matter what I say. Like, they don't get veto over the video. And honestly, I probably won't run into too many more of those, you know, opportunities. I don't think most companies are going to be that generous with their equipment, knowing that they don't have any say over what ends up coming out, unless you're, you know, a proper Sky and Telescope type publication, and I'm not. I'm just social media, right? So it's one thing when you're handing it to the editors of Sky and Telescope or Astronomy magazine. It's another when it's, you know, some random goofball in Florida with a YouTube channel. But hey, if any companies out there want to send me a piece of astronomy equipment to review, I'll be happy to do it. Just please don't send me a terms and conditions sheet that requires that I submit my video to you for your final approval. Because I've learned the hard way, unfortunately. That is ick. That is all kinds of ick. So I'm wondering about the time lapse, or the final time lapse. I do have some other software I wrote for the time lapses I did for Artemis 1 during its return that should annotate the images with the identifications of satellites passing through the frame. The way it's written right now, though, it basically... Well, no, it ought to work. It ought to work at this scale. So it looks at the position of... It takes a TLE file, the orbital elements file, 3-line elements or 2-line elements. It's really 2-line elements, but the third line is the ID. Anyway, it takes the elements file, and it goes through and parses each set of elements, and it calculates where that satellite would be during the time the picture was taken, and if it's in the frame, it puts the name of it in the frame. Speaking of time, I should double check. I meant to check the time. Okay. Clock was last synced 9 days ago. Oh no! Okay. Wheel. I'm not so happy about that. Okay, let's see. If I sync now, it's a few seconds earlier. Okay, so yeah, that's great. That's... Okay, so my images are a few seconds off. So, right, that doesn't help. So my computer clock was running about 3 seconds fast for the first 2 hours of images, 2 hours and 20 minutes of images. I should have synced. Always sync your computer clock when doing astronomy like this. So yeah, my image times and the headers of each of my images are going to be 3 seconds too fast. So for satellites that shoot through the view in, a couple seconds, the image here is about 1.5 degrees wide, so something in low Earth orbit is going to take maybe 1.5 seconds to pass through. So when your computer clock is 3 seconds off, that's a problem, right? It's not going to put the name where the name ought to be. I can rewrite the code a little bit and have it... yeah, that adds some complication. Because before, it was dead simple. It just take the time of the picture as gospel and render me the names of every satellite, and if it's in the frame, render it onto the frame. Well, it's not really checking whether it's in the frame, is the thing. It just renders it. It doesn't care whether it's in the frame or not. It won't appear if it's not in the frame. If the pixel values are of where it should put the name are outside the frame, then there's just not going to be anything there. So now I'd have to tell it, okay, I want you to actually look to see if the position is in frame, and if it is, render the name once. Tell me what it is. But I want you to look over a span of time now. Instead of just taking the image time as gospel, I want you to integrate over a few seconds either side of the image time and tell me if it's in frame or not. And though I didn't intend to grab astrometry of the asteroid and try to solve the orbit, obviously now that I know my clock was off, I can't reliably do that. Because as you can see, this asteroid's moving relatively quick. You don't want your computer clock to be a few seconds off when you're trying to solve for the orbit. Now, I could use however many images I get after this, 2 hour, 20-minute point. Those are okay. But the ones all throughout the first part of the stream are not okay. If I'm still doing this in 2029, well, I hope I am. Don't jinx me like that. Do I plan to track Apophis? Yes, in fact, I've tracked Apophis before. And I meant to do more videos about that, and I haven't gotten around to it. Sort of put that on the back burner, haven't I? But I think I even have some data on Apophis I've never even published that I've grabbed from my telescope or whatever. I did have some tracking of it that I actually did publish as a YouTube short on my channel. But yes, when it comes back around in 2029, I hope to track it again. Oh, now? Well, not right now. I mean, the images are on my hard drive somewhere. I've got to dig them up and process them. But the software I used to create the time-lapse, I actually wrote the program that created the time-lapse. It takes the raw FITS files. So, for background, these cameras, these astronomy cameras, like the one I'm using tonight, they don't just take JPEG pictures. It's not like a consumer camera. It's recording raw data with no processing on it. So it's saving what we call a FITS file. FITS is the standard image format of astronomy, and it's recording the raw pixel values for each pixel, and each pixel has been pre-filtered for red, green, or blue. It's in a repeating matrix pattern of 1 red, 2 green, and 1 blue pixel. And this pattern repeats all over the CCD, all over the detector. But the image files just have the raw pixel values. Some of the pixels are red pixels, some of the pixels are blue, some of them are green pixels. None of that is necessarily encoded in the file, other than here's the type of camera, go decode it yourself. Go debayer the image yourself, all this stuff. There's all these processing steps that your typical consumer digital camera on your phone or a handheld camera does automatically. You don't even see it happen. It's hidden behind the scenes, but when you click the shutter, within a split second, the miniature computer that's in that camera is actually crunching numbers. It's interpolating the picture that you see, because the picture you see is composed of pixels that were each filtered for a specific color in a repeating matrix pattern, and then it's doing some fancy math to actually interpolate the full resolution picture. So this camera doesn't do any of that. It just records the raw data onto the hard drive. Then you have to use your own software. You can buy software, or you can even write your own to process that. So my program takes the debayered version of the image, so I pass it through a different program first, and all that program does is basically says, okay, well, I know what the pattern is for this type of camera, for the S-Big camera that I'm using. It says, oh, I know what the order of pixels it is. This one's red, this one was green, this one was green, this one was blue, and it does this repeating pattern. And so it does the math on the interpolation of that color picture. Again, all digital cameras do this. You just don't see it happen. It's just automatic inside the camera when you click the shutter. I have to do this on the computer as a separate step. So it does that interpolation, and then it goes into my program that then takes each of the pictures, and these are high bit depth pictures. Each pixel is not 0 to 255 in brightness. Your typical digital camera, these days more digital cameras have HDR capability, but most just bottom of the barrel consumer cameras, when you click the shutter, it gives you a JPEG. That JPEG has encoded brightness values for each color channel, red, green, and blue color channels, from 0 to 255. This camera has high bit depth, and so the values are not 0 to 255. The values of brightness go from 0 to 255 squared. 255 times 255. And so you have to crunch that down to 8 bits. So you can do fancy tone mapping with it, and I've got a program that can do it that way, but that's not always the best way to do it. Or more frequently what I do, like with this time-lapse, is I just tell it, okay, instead of the values going from 0 to 65,500 whatever, I want you, Mr. Program, to grab the image and interpret anything below this pixel value as pure black, and anything this pixel value or above is pure white. Okay, so you're just grabbing a portion of the histogram. And then you're doing some simple linear math to convert that to values that span 0 to 255. That's an 8-bit image. That can be converted to a regular JPEG that other people can use and see. The format that it comes in, this FITS format, is something that a lot of programs can't even necessarily open natively without plugins or something else. And they're high bit depth. They're not something that your monitor can natively display. So my program comes in and says, okay, here's the minimum and maximum brightness values for the output images. And then it puts them together into a time lapse. It also does automatic calibration between images, because this camera can vary a little bit in sensitivity from one picture to the next. And so if you don't compensate for that, the resulting time lapse has this awful strobing effect where it looks like the whole image keeps getting brighter and darker from frame to frame, and it makes it look like it's trying to cause you an epileptic seizure when you look at it. So instead of just taking the values from saying, okay, this value is going to be pure black, this value is going to be pure white, it says, okay, let me first analyze the image and see where the median value of brightness is. The median value is generally going to be driven by all that dark space in the picture, the background sky level. And so if you calibrate to that, then it doesn't strobe anymore. Now it looks steady and nice. So I wrote the program that does that, and I'm very happy with it because it makes it very easy, very fast to make these time lapses. All I have to do is dump the frames in there, it batch processes them, and out comes the time lapse. Wonderful. Years ago, I used to have to sit down at the computer and by hand process each one of these pictures, 100, 200 pictures, into JPEG images that then get put into a time lapse. Boy, was that time consuming. That got old real fast. So I'm very glad I figured out how to write Python code and handle FITS files with Python. Very powerful feature to have. Yeah, yeah, exactly, John. NEAT time. I forgot what it was called, but I think that's what I had heard of. Yeah, this GPS for conditioned PC time to milliseconds, very cheap software and cheap GPS antenna. I actually have a GPS antenna for this laptop, not plugged in right now, but yeah, I could use that. I could definitely do that. I should have done that. I should have just synced, honestly. For most purposes, just syncing the computer clock with Windows time is good enough, quote unquote. Certainly, the way you suggested with the proper GPS antenna and getting GPS time, that is going to be the most accurate way to do it, of course. And there's programs out there to embed that data directly into the image. So instead of just pulling from the computer clock, you could even, I wonder if you could even write your own. I guess you'd have to interface with the SBIG drivers, but probably write your own software to do image acquisition and embed the time not from the computer clock but from direct GPS antenna time or something like that. That'd be fun. Sounds like a fun project anyway in my head. So anyway, my whole long tangent about the time-lapse software was just to say I have to go find the Apophis images that I took and dump them into the new time-lapse software I have, because I think the last time I did an Apophis time-lapse, I want to say it was right before I made this software. So a lot of those images are probably languishing somewhere on my hard drive, never have been processed because I didn't have the software to automate that process and make it easy and fast. Hey, SlickX. Yeah, I'm glad you could be here too. Tell you what, I'm going to take a quick peek in the telescope and see how it compares to the view I saw earlier before I ate, and see if that dot is still in the same spot in the eyepiece. Ugh. Yeah, that's interesting. I don't see anything in the eyepiece now, so I think what I was seeing before was probably just a background star and had not been the asteroid. But the refractor that we're shooting with is not perfectly co-aligned with the main telescope, so just because it's in the field of view of the camera doesn't mean it's in the field of view of the eyepiece that I have on the main telescope, unfortunately. Yeah, it's the small dot that's wiggling a little bit back and forth in the time-lapse. The other dots that are perfectly stationary in the time-lapse are just hot pixels. There's a couple cosmic ray strikes in there as well, and then there's some satellites streaking through very quickly. But the asteroid is the small dot wiggling a little bit in the time-lapse. And I've also got the arrow pointing to it in the live image. Are we doomed? No, we're not doomed. Just a heads up, though, we're going to wrap it up around midnight. We're getting the 153rd image here, so let's see. I'm going to say when we hit 3 hours on the asteroid, we're going to wrap it up. So we'll go to 180 images. You can see the image count on the bottom right there. Wonder if I can just paste. Okay, I need for that to be up there. That above the time lapse. Yeah, you get the idea. Hopefully that'll help people. Stocking up on toilet paper and bottled water just to make sure. I mean, you might want to do that anyway. Nothing to do with an asteroid, but always good to be prepared for an emergency, right? I tell you what, I'm having to live off bottled water right now. They are currently flushing our water system with chlorine. So it's like drinking pool water. It's awful. It's like showering in pool water. It's awful. It's all awful. The water coming out of my pipes right now in my house has just an awful strong smell of chlorine. It's terrible. And they say, oh, it's perfectly healthy, it's fine, don't worry about it. But who wants to drink pool water? Who wants to cook with pool water? Really? It smells terrible. So, it's bad. Now, if you boil it for 15 minutes, it does boil off, but it's not great. So, it's a lot of bottled water for me right now anyway. You hope it brings back Elvis. I mean, who knows, right? I have to be careful, though. I mean, people will, unfortunately, try to make hay out of mundane stuff and try to make it seem like it's something it's not, and that can lead to bad things. I mean, famously, the Heaven's Gate mass suicide it all started because of the cult, but the cult's final descent into madness and ultimately mass suicide was driven by an amateur astronomer who was taking pictures of Comet Hale-Bopp and thought he saw something near the comet following it. It was just a background star, I think, but he said, he went on, a radio show and said, "Oh, I found a UFO trailing the comet." Sounds fun, sounds exciting, right? Well, the cult took this as the sign that the time was here to beam up to the mothership following the comet, and, they all killed themselves, so that's not great. So, for anyone who is going to maybe try to think about using my time-lapse as evidence that this is, in fact, the mothership they need to beam up to because, it's clearly not natural. It's wobbling back and forth. Normal asteroids don't do that. That's just the motors. That's just the tracking. It's nothing to do with the asteroid. That's what we call periodic error. So I've used that term a few times earlier in the stream, but to give you a better description for those who don't know, periodic error is a natural phenomenon caused by the telescope. It's a natural fault of the telescope that the gears of the telescope are not perfectly round. I mean, by eye, sure, they look round, they look nice and everything, but this is an LX200. It's not the world's most expensive telescope. It's decent, but the gears are not perfectly round. And so they turn one rotation every, I think, 8 minutes or so. And so there's a periodicity to it. It's very regular, but because they're not perfectly round, at various points in that rotation, even though the motors are being turned at a fixed speed, because the gear itself is not perfectly round, it causes the telescope to move a little bit too fast and then a little bit too slow. On average, it'll move the right velocity, but at any given moment, it's going to be a little too fast or a little too slow, and it's going to repeat that pattern every 8 minutes or so. And so every eight images or so, it's going to wobble to the left and then back to the right. So it does this woo, 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 woo through the time lapse like that. And that's periodic error. So, if you watch the asteroid in the time-lapse, I count 8 repetitions of that wobble. I'm looking at where it juts to the left, because it kind of juts to the left and then goes back a little to the right. Over time, it's gradually moving to the left, right? It's drifting a little bit to the left. But the wobble within that drift, looking at how it's jutting left and right, if I'm just counting when it kind of jerks to the left, it kind of does it, I want to say, 8 times. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, and then it repeats. And so, if we assume the motors, like I said, off the top of my head, from memory, I want to say that the rotation period of the gears on this telescope is 8 minutes. And there's 65 minutes of light, roughly, in that time lapse. 65 1-minute images. 65 divided by 8 is 8.125. Exactly. So, that's exactly as many wobbles as we would expect to see due to periodic error, given the rotation rate and period of the gears of the telescope. How big is it? Depends on the reflectivity, which we don't know. I don't know if there's been any radar data on this particular asteroid yet. Maybe there will be. But based on the absolute brightness, the absolute magnitude, if we assume that it's a fairly dark asteroid, that would put us at the higher end of the size possibilities. So if we assume maybe it's as dark as fresh asphalt, okay, that would give it about 5% reflectivity, and that would imply a physical size of about 88 meters, roughly. However, for some reason, the media lately has been wanting to describe asteroids not in terms of feet or meters, but in terms of random objects, particularly animals like giraffes or alligators or something. So I came up with a new scale tonight based on the telescope that I'm using to actually see the asteroid. It's got a focal length of 400 millimeters. That's from lens to where the image plane forms. So if you divide 88 meters by 400, you get 400 millimeters, 88 meters by 400 millimeters, or 0.4 meters, you get 220. So the asteroid is 220 telescopes long. Why the media is insisting on using random objects to describe the size of asteroids, I don't know, but I guess it gets the clicks. Yeah, remember Hale-Bopp? It stayed in the sky for months, and you could see it in the daytime. Nobody really cared, but I thought it was cool and kind of spooky. I never saw it in the daytime, but I definitely remember seeing Hale-Bopp. I lived in Florida at the time it first sort of appeared, but moved to Colorado during the apparition, and I distinctly remember seeing it in both locations, before and after the move. It was one of those, it was, I think, probably the longest lasting bright comet of my lifetime. And it was pretty special. Worst major moon in the solar system? I don't know. What did I miss here? Worst major moon of the solar system. You're asking me what I think is the worst major moon of the solar system? I don't really have a worst, I guess. I never thought of ranking asteroids in terms of worst to best. I mean, I'm, of course, partial to our own moon, as far as best moons go. Having a moon that can produce a nice total solar eclipse is just nice. This is D tier. Okay, I won't argue with you. I've just never heard of anyone having an anti-favorite moon or least favorite moon. Hale-Bopp blew Halley's Comet away. Yeah, no, it definitely did. Do we have any other visible comets coming soon? How soon can we detect stuff like that? Well, that's a great question. And yeah, there's the potential for a decent comet. Nothing like Hale-Bopp, though. So let's see, what's that one that's supposed to be? Supposed to be coming up that's good. Yeah, there was ZTF. What was the other one? There was another one. We just had C2022 E3 ZTF. Was that the one I was thinking of? I thought there was another one. Oh, maybe I was thinking of C2023 A3? Yeah, this is the one I was thinking of. This is coming up later in 2024. It's supposed to get within 4/10 of an astronomical unit of the Sun in September 2024. Could brighten as much as magnitude 0, but that's when it's, really close to the Sun. It's currently magnitude 17. Need a really good scope to see it. I mean, I would probably have to pull out the 11-inch to even have a hope of picking it up, really. So this was C2023 A3, and boy, I'm gonna butcher that name. Suchinishan Atlas. Apologies for the butchering of the name there. Been so tempted to buy some of the telescopes on eBay. Might just buy a computerized mount for the telescopes I've got already got double scope. I mean, yeah, if you really want to do things proper, you probably should buy the mount separately anyway. Celestron makes some good equatorial mounts. The CGX, for example. I know, Skywatcher telescopes make some good stuff, although I am not as big a fan of theirs, just because some scopes, it's totally a personal beef kind of thing, but some scopes don't always support the move axis method by ASCOM, and I feel like I'm always beating that dead horse, but my software, like the program I'm using right now to track this asteroid, depends on using that method. It uses that method to directly control the scope drive rates. Of course, I'm not using that method right now because I'm using the LX200, but when I do satellite tracking or rocket tracking, though I wouldn't use an equatorial mount necessarily to do rocket tracking, but certainly you could do it for satellite tracking, I need to be able to use that method. So I refuse to buy a scope that doesn't support that method. It just doesn't make any sense for me not to. So until you get into the really high-end stuff like, plane wave type stuff, I would insist on getting a mount that supported that method. But that has to do with my personal interest in satellite tracking and wanting to do that as part of the hobby for me. So that limits my options right out of the gate, honestly, in terms of what I'm willing to look at. 103p Hartley stream at perihelion? Maybe. Maybe, if I can find the weather and the time. .103p Hartley, so that's September. Should be able to. Summer can be tough sometimes, but you get into fall and its possibilities open up. Alright, so we're going to get another 5 images here, and then I'm going to process one more time lapse. Hopefully not destroy the streaming quality by using my desktop again. Last time I used the desktop tonight, it somehow decided to start sucking up all the upstream bandwidth and nearly killed the stream. I've now set the laptop that's actually running the camera here and streaming to YouTube as the priority device on my network, so it shouldn't do that again. Knock on wood. It should prioritize the laptop bandwidth over the desktop now, but I will process the images, all 180 of them, and run them into one final time-lapse to show you guys the progress we made tonight tracking Asteroid 2023 DZ2. Yeah, sounds good, Slick. Alright, so I'm going to go ahead and get in position on the desktop and get ready to process 180 images. We should have completed that in a couple of minutes, so I will be right back with the final time-lapse, and then we'll close out the stream. So stay tuned. Alright. The time lapse is ready. Let me go ahead and pull it up here. Okay, let me fix this other window first. Oops, didn't mean to turn it off, I meant to fix it. Oh. Alright, so let's go ahead and pull up the time lapse now. So this is going to be the complete time lapse of 3 hours of images that we've collected during this webcast. Here it is. Let me shrink this a little bit. It's a little bit... vertical resolution's a little higher than the screen resolution of the camera. Or screen resolution of the computer. There it is. So the asteroid is right here. Hopefully that's coming through okay on stream. I'm pretty happy with that. Pretty happy with that result. Alright, so that's going to do it for this stream. Hope you guys enjoyed it. I'll take this this time lapse, maybe adjust the contrast on it a little bit, and upload it to Twitter. Probably upload it as a YouTube short as well, so you guys can look back on it at full resolution. But yeah, this was Asteroid 2023 DC2 approaching Earth. Just for completeness, let's check out what the current distance is. So we're at 1233 right now. So the distance at the end of this time lapse was roughly... Come on. Oh. Why is my internet struggling? That's not good. Okay, well, if you guys can still hear me, the distance at the end of the time lapse is about 449,000 kilometers. Which is about 1.17 times the distance to the moon. So it's inching ever closer to being equal to us in the distance between us and the moon. But anyway, yeah, I'm going to go ahead and wrap up this stream, and like I said, I'll post the completed time-lapse to Twitter and YouTube Shorts later. So thanks for watching, everyone, and until next time, clear skies.